Jai Hind everyone. I Rupak Kumar from IT department. Today I am going to a basic overview of computer network which is in 6th semester in AKTU. So first we start with what is network model. We discuss about the network model, that is what the layered, or we can say it is a network is basically a layered task. Layered task means an international standard organization, that is ISO, a proposed and open system interconnection, that is OSI model, and allow two systems to communicate regardless of their. So ISO, that is International Organizations of Standardization, that is what they propose, the OSI model. Basically, it is a hypothetical model. Hypothetical model means it is not in used, but it is the reference model. We take reference of this model and then we create a different model like TCP/IP, NetBEUI, SXPX, and many others models, and then we implement it on our system to communicate with each other. So it is the matter of communications. While we just discussing in international organizations that how we communicate, there must be some protocols for communications. So in terms of that, they proposed open system interconnection models. That is what is open system interconnection model. It is basically open system is a set of protocol and that allow any two different system, means they allow the any two different system, that allow any two different system to communicate. That is what, if the system has different network, but how they can communicate, it is that OSI model, reference models, by which we can communicate with each other even if we are in a different network. So the purpose of OSI model is to show how to facilitate the communication between different systems without requiring change to their logic of the underlying hardware and software. Means without knowing what is the configuration of the system, what is the hardware, what is the software, we can communicate with each other, and this is possible only with with that international organization open system interconnection, that is proposed by international organization ISO, International Standard Organization. They propose open system interconnections to facilitate the communication between two different networks. So the OSI model is not a protocol. We can say it is a models for understanding and designing a network architecture that is flexible, robust, and interportable. Means it is the model by which we can communicate with different types of system, even if we do not know what is the configuration, what is the hardware, what is the software of that system, but we can communicate with that. So this is what our proposed OSI model, and this OSI model contained 7 layers. So we see that 7 layer of OSI model. The layer start from bottom, that is what first layer is, very first layer is your physical layer. Then we have a very first layer here is physical layer. This is what the physical layer. Then we have a data link layer, network layer, transport layer, session, presentation, and application. So this is what the 7th layers by which we communicate with each other. So data is just starting from that physical layer, first layer, and that is what the data bus or the medium. Means what is the medium of communication. This is decided by the very first layer of the OSI model, that is what physical layer. Means data bus, that is what to communicate with another system. So this is a one side of a system. We see that is what sender point. Then we have a next layer is data link layer. In data link layer, we have a different protocols is working, that is DH, NHDH, SHPH, AU, data, and data. So this is what the second layer of the OSI model. We'll discuss it on later. Next layer is network layer. In network layer, we have a different protocols, and we have a data. Means they just take this data from the lower layer and added their own stamp, and then they pass to the upper layer. This is what the network layer, and they also contain data that is coming from the lower layer. Fourth is your transport layer. It is also have their own network header. This is what the data link layer header, that is what the network header, that is what the transport header. They just adding their header, session header, physical header, and application header. They just adding their header to the data, that is what in the different layer. So this is what the proposed application layer, which contains 7 layer: physical, data, network, transport, session, presentation, and application. Like that, how they constitute? They are just physical data link layer. In network layer, we have a different protocols like ICMP, IGMP, IP, ARP, RARP. This is what the some of the different protocols in this layer. Next is your transport layer. Transport layer, in transport layer we have a two important protocol is there, that is what we call a TCP, that is transport transmission control protocols, and another is your UDP, user datagram protocols. These two protocols are very important for communication. Nowadays we are using TCP, means TCP IP is the protocol. TCP, you can say like that, transmission control protocol over internet protocol is the protocol used by more than 96% of network device, or we can say system, computer, mobile phone, and whatever. They all are using only this TCP IP protocol. Then next four is other protocol, that is what SXPX and many other protocols. This is what how we can communicate with these protocols. The TCP IP is the most widely used protocol, that is what in a transport layer. Next is your application presentation session. That is what in application presentation session we have a different SMTP, simple mail transfer protocol, file transfer protocol, telnet, DNS, SNMP. So many other protocols, that is what find in all these 3 layers. Okay, so this is what we can say how we communicate over this. How the devices communicate? There is a device 1 and device 2. All these two devices are communicate with each other through internet. So this is what all the 7 layers are working while they communicate. These layers are working on both the device A and device B. We have a physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Clear? So this is what they work on this layer. Next is your, this is what the protocols that is used in a different layer. Next is your how the device 1 is communicate with device 2. This is what the physical layer, data link layer, and transport layer. The transport layer is used to sending the responsibility of data from device A to device B. Now, what is the physical layer? Physical layer is basically the very first layer of the network. That is what physical layer is that is what they communicate with. The physical layer is that by which they connected, how the system or network is connected with each other. That is what responsibility of the physical layer. Physical layer means the how the cable is connected with each other. Okay, so this is what the network cables, or we can say it is with the help of Wi-Fi and all. So this is the connections, physical connections is responsible for the very first layer of the OSI model. That is what the physical layer. Next is your data link layer. So in physical layer we have just bits, means our data is just converted into bits only, and they transfer the bits to the next layer. That is what very first second layer, data link layer. In this data link layer, this is what the data, and they just convert these data bits to a frame. Means in the second layer, the data bits is now frame. Means that is what we have a MAC header, means the physical address, then IP address, TCP IP header, HTTP header, then data that is coming from the lower layer. And this is what the combinedly known as frame in this layer. So this is what the bits in very first layer, bits in very first layer, bits in very first layer, then it is frame in second layer. Means they just bind up that data with their headers. That is what called frame in a second layer. Next layer is network layer. Network layer is responsible for the network of that data. Means what is the IP address, what is the IP address, what is the MAC address, and they all, how the data is sending from one node to another node. These all are responsible of a responsibility of a network layer. They added their header to that that frame, and then they just send to the network. Next is your transport layer. Transport layer is basically responsible for transmission control. How the data is transmitted, it is controlled by the transport layer. In transport layer, we just sending the data and with the help of transmission control protocol or UDP protocol. It depends, it's a reliable or not. So these two protocols, TCP and UDP. TCP is the reliable and slowest network, but UDP is the fastest but not reliable. This is what difference we'll see in a next file. Let's go later on. Next is your how device is communicated. They just one device A and device B want to communicate. How they communicate? There is the segments. Segments means sequence number of that, port number of that data, then sequence number 2, port number and data, sequence number 1, port number and data, sequence number 4, port number and data. This is what the packet they just combine and make a segment and then send over the network. So first sequence, that is what sequence number 1, port 1 and data is here, and second sequence is sending, third is sending. This is what how the sequentially data is sending in a network. This is what the checksum. Checksum means just IP header, TCP IP header, and a checksum is added to the network so that how they communicate with a server to a communication. Now, if you talk about TCP, UDP, that is very simpler and faster, but it is not reliable. But if you talk about TCP, it is very reliable protocol. So this is next is your how this data is communicated from one device to another. It is with the TCP segment UDP packet. And in this, that what is the how the UDP is work. The UDP is very faster communication. So while in video and all we use TCP, but in we can say sending text message or some reliable things, we are just using TCP. The source, this is what the source IP address of destinations means. What is the IP address of this device? That is what in an IP header. Then we have a transmission control protocol header is added with this IP address. Then we have a HTTP header that is added in this IP address. Then we have a data, that is IP datagram, that is what added in this. Then how the data is sending? Data is sending from physical layer to this layer, and then HTTP header is added to that data. And this header is the basically data packet. It's a bit is sending to the next TCP segment UDP packet. Then this packet is sending to the next layer, and again that is what sending to the this and added the next header. I mean, every layer is going to added their header with that network. This is what the final means. In final, we can say with the bits from very first layer is just sending to the upper layer. It's upper layer, that is what in a data link layer, and thus they added their header. In that is frame is then IP datagram, that is what the next layer is sending to this. Means data is coming from how the data is sending. So data is coming from the first device, which is sender and receiver. Sender sends the data and added their HTTP header to that data and send this data to the second layer, and then they added their header, that is what transmission control protocol TCP header to that data. Means this data is similar. No? It is what coming from the this layer. Then they added their header in this. Likewise, these all data is same in all layers, but they added, this is all the same for this TCP IP. They added IP header in the network layer. They added MAC header in a data link layer. Means the physical address is added in this data link layer. This is what the bits physical layer. In physical layer we have a bits, that is what sending to all the upper layer. So this is what the OSI model by which we can see that how we communicate with each other throughout this different configurational device. Means it is not necessary that the configuration of our device which is connected in network is same. So that is what it is responsible of OSI model to communication. From that OSI model, we just take it as reference, and we create many models like TCP/IP, UDP, SXPX, NetBoI, and many more models created. But nowadays, TCP/IP is the most reliable and mostly used models in this networking. So next important is what is the network, computer network components. We have a modem, NIC card, repeater, hub, switch, router, bridge, gateway. There's many more network device. So if we start with the first network device, that is how the computer network are connected with this device. This is what the scenario where we connected as many as device. Computer network components comprise of the physical parts as well as the software required for installing the computer network. So both the organizations and at homes. So first, it is the internet which is connected with the routers to our all the device. It may be some computer, it may be some two other network. By this is what the network is divided in with the help of this bridge. This is also one of the network device, and in this we see the transmission mode. In transmission mode, we can have a cables, or we can have a Wi-Fi. Many all these are connected with this transmission media and a different system or computer. We have a printer. Then if the signals is moving from very far away, then we take our next network device, that is what repeater. They repeat the signal, they enhance the signals and sending to the network device. And this side of bridge, that is what we have a hub. Means we connect as many as system from this hub. So we can have a server connected with this hub. Different system and workstation is connected. This is what a basic scenario of computer network, and how all this component is connected with this network. This is how we connect our devices. So now come for the very first device by which we connect our internet. That is what NIC card. NIC card means network interface card. It is basically a computer hardware used to connect a computer with another computer onto a network. If you want to connect a two computer in a network, then we must need a connectors, and that connector is known as NIC card. That is what network interface card. So NIC basically essential for a computer to access and communicate with other device on a network. So if we want to communicate with any other device in network, we must have to connect that device with another device, and that is what the connection is with the help of network interface card. We connect our cables with this card only. We connect our Wi-Fi with this different NIC card. So including other computers like server, routers and switches. So without which a computer cannot be connected over a network. This is what the NIC card. So it is not possible to connect a computer without NIC card. Next is your event switch, and the routers use NIC to connect to the network. So what is the MAC? That is medium access control, media access control. MAC is also known as physical address or a unique address. That is what identify for each host associated with a network interface card. So with this MAC address, computer connected to NIC and can be recognized on the internet. Means MAC, there is two address when any computer or system is connected. If any computer or system is connected, suppose we have two computer 1 and computer 2. This is connected with the help of NIC card on both the device. Then only this medium is connected with NIC card. Now we have two types of address in every device. One important address is your MAC address, another is your IP address. This is also the MAC and IP. MAC address and IP address. So this is what the MAC address we are just talking about. MAC address is basically media access control address, and this address is given by government organizations to the company which is making this computer device. and they just burn that address, that 48-bit address. It is a 32-bit or 128 account, depends on IPv4 and IPv6, and this 48-bit hexadecimal numbers is burned in this NIC card. This is what the MAC address, media access control, and that is what which this MAC address component connected to the NIC can be recognized on the internet. This is what the two address with the help of which we recognize our system in the network. Clear? Okay. So next is your network interface card, wired NIC or wireless NIC. There are two type of NIC card with by which we just in this we connect the wired in this slot. We connect the wire in this slot, and in this is what the wireless or the computer is connected with this Wi-Fi or wireless. So the wired NIC is presented inside the motherboard or cables and connected, and that is what connectors are used with the wired NIC to transfer data, or wireless NIC, the wireless NIC connected to the antenna to obtain the connection over the wireless network. Laptop computer contains the wireless NIC. Hub. A hub hardware device is networking that is used to connect the multiple computers. What is hub? When we want to connect a multiple computer in a network, so we can connect the things from this network, and we want to connect a multiple device, multiple station, multiple nodes, then it is the hub used. Means it is a hardware device in a networking that is used to connect a multiple computers. So this is what the network device which works in the first layer of OSI model. It is work in a very first layer of OSI models. That is what the physical layer. So the hub has many ports in it, and they are generally used to connect the computer in a local area network. If you have in a local area, we connect this hub in LAN. Clear? Next is how hub is connected. This is a digital multiplexer used to make a point-to-point connections. This is what the hub, and all the stations, all the receivers, or we can say all the receivers is connected with this hub, and they are connected with a sender. When sender sends a data, and it can be received by many system or computer, and that is what only with the help of this hub device. This is what responsible for connections of all the other device. Clear? Now hub. There are mainly three types of hub is there: passive hub, active hub, and intelligent hub. So passive hub, active hub is not used now. Now we are using intelligent hub. What is passive hub? Passive hub basically a very simple connectors or a device together without any signal amplifications or even not regeneration of the any signals. It has no power source and does not boost the signals. Means if we connect with a passive hub, so they just take the signal from that sender and they just send it to broadcast to the all other. They are not even bothered to recognize, or we cannot, they not enhance these signals. Active hub, and active hub also known as a powered hub and has a power source and can be generated and amplify the signal. ये क्या करता है? This is what they just generate take the power. इसमें power चाहिए होता है इस वाले में, और ये क्या करता है? Regenerate भी करता है and then amplify भी करता है. Just amplify and regenerate the signals. Clear? अगर इसमें एक्टिव हब लगा रहेगा तो दे जस्ट कमिंग फ्रॉम दिस सिग्नल, दे जस्ट regenerate and just amplify the signals, yani enhancing the signals. Next is your intelligent hub. This is very important using nowadays. An intelligent hub is also known as managed hub, provides the additional features and capability beyond these of a passive or active hub. It can monitor and manage the network traffic. Means it is taking response to as a manager. Means they are managing the network. Now it prioritizes the data transmissions and provides the network security feature. This is very intelligent device, and it's also known as the managed hub. Means they are managing our network. Means they are just additional feature that capable of beyond this of a passive or active hub. This is what upper upper segment of this. This is more than that passive, or we can say active hub. है ना? It can monitor and manage the network traffic. So this is nowadays this hub is only using. Next is bridge. A bridge. This is what the bridge just divide the single network in a two part. So bridge is a network device or a component of a computer network that connects two or more network segments together. Means there is a different network, and if you want to connect this network, we are using bridge. A bridge, what the bridge do? They just, if the signal is coming to the bridge, they know it is sending to the A side or B side, because it contains all the addresses of this device. So if the address someone sending for B side, they just send it to B. So no need to know about A, but when the signal is coming for A, just sending to in A part. This is what a bridge operates at the data link layers of the OSI models, and it is also known as layer 2 switch. Bridge is only, that is what known as layer 2 switch. So the bridge has one input port and one output port. Only one input and one output port is there. Bridge checks the destination address before sending the data. But they just check what is the destination address. It is from for the B side, then they send it to B. It is for the A side, then they send it to A. So this is what the bridge has, the input port and output port. So bridge checks the destination address before sending the data. If the bridge finds the destination address, and then it serves the data, otherwise it does not transmit the data. Now bridge, types of bridge, we have a local bridge, remote bridge and wireless bridge. There are three types of bridges there. First is your network bridge. That is, network bridge is responsible for just sending data to the network, and they just create a make a tables for that. They have a tables of a port number, and this is what the table created by the bridge. Port number 1, port number 2. Means in port number 1, this is 1, you can say, and this is port number 2. So in port number 1, they have a device A, B, C, D, and in port number 2, device E, F, G, H. So any data coming from the network, they just sending, just seeing that it is related to which port. If it is a port 1, that is what it may be, A, B or C, C or D. Then they send it to this side only, port 1 side. This is what how the next is switch. Switch is basically a hardware device, and it mainly responsible. It is mainly resembles a bridge. Means a switch contains more advanced features than bridge. Means switch is the upper segments of, we can say, bridge. So switch is a device that connects multiple devices on a computer network, and we can say a switch is a data link layer device, and it operates in a layer 2. It is also a layer 2 device like bridge. So data link layer of the OSI model is contains the switch, one of the device. So when the data frame arrives at any port of the network switch, it examines the destination's address and perform the necessary checks, and then send the frame to the corresponding device. Means it is a very intelligent device that it first check the data is sending to which device, and that they contains the MAC tables or IP tables to sending the data. Next is router. Router is basically a hardware network device or a component. It is the network that operates in the network layers of OSI model. It is a very third layer of the OSI model, and it is used to receive, analyze and forward the incoming packets to another network. Means if you want to connect two networks, then we have routers. Router determines the best path from a available paths of the transmissions of the packet, and it uses the connect a LAN with an internet connections, routers using the routing protocols to transform the data in the network. So router is quite expensive as a component to another network device like switch and hub. So router is basically, we have a wireless or Wi-Fi router, we have a B routers, core routers, edge routers and virtual routers. So there we can say nowadays we have a 5 types of router in our networking. Next is modem. Modem is basically modulator and demodulator. Modem stands for a modulate, demodulate a data. A modem is a network device of a computer network that is used to convert digital signals to analog signals and analog signals to digital signals. This is what the main function of work, that modulator and demodulator, they just convert the signals analog to digital, digital to analog. So model convert digital signals from a computers or a network into a analog signals, and that can be transmitted over the telephone line or a cable. So this is the work of modem, that they transmit the data and they convert it digital to analog. So when the analog signals reaches to the other ends of the line, the modems on the other end convert the analog signals back to the digital signals, and then they understand the receiving computer network. So we can say modulation is the process of encoding information transmitted signals, while demodulation is the process of extracting informations from the transmitted signal. This is what the work of modem. So modem is of two type: internal modem and external modem. As the name suggested, internal modems in a internal part inside a computer, and external modem basically a external modems in a external part of the computer. So it can use when a computer is unable to fit an internal modem inside of it. Thank you. This is all about your network device. In next class, we'll see another.